Right, array lists come also in the library of Java. So you can say import Java util linked list, and you will have it. And you can just call add first, at last, you have all the methods there. Yes, Carlos?
What's the difference between like an array list and a linked list?
An array list, behind the scenes, is an array that is being doubled all the time. So it's not really dynamic memory. An array list provides some sort of random access. They are arrays behind the scenes. Linked lists are sequential access, right? So that's the disadvantage, and the advantage is that it's dynamic memory, right? As needed. Now, stacks and queues. We're going to start with stacks first. Okay? Stacks are yet another data structure. Okay? Data structure means a structure where I store data. Now, what's the thing with the stacks and queues? You can also import them from import Java util stack. Okay? Import Java util queue. But then you don't learn how they work. You just learn how to use them. And that's not really what I intended for you guys. So I'm going to really teach you what's a stack, how do you create stacks, what's behind them. So the idea of a stack, we normally represent a stack like this. It's the same idea as the English word stack. What does stack mean? A pile, right? But it has an important property. Imagine you give me your assignments here, and like you normally do, and you put the assignments on top. If say this comes and puts here assignment first, and then comes the link, and then say Yuken, and then Shri. Okay, for assignments. What's the assignment I will grade first? Shri, because she was the last one to put the assignment, and will be the one on top. But who was the one that put the assignment first? Sales. But that will be the last one I grade, because it's the one that was first put. So stacks are called what? They're called LIFOs, right? Last in will be the first out. The last that was put will be the first one I service. Got it? Yes? So, they have this important property called LIFO. Okay? So, they are last in, first out. So, a stack is a collection of elements in the end, right? So, what can we use to represent a collection of elements? We can use linked list if we want to use dynamic memory. We can use an array. We can use an array list, right? And we can use other type of collection. But let's play with these three, right? Which one do you think we're going to use? Linked list? You wish. I will not. Okay? I will use arrays. In simple, you need dimension and arrays. Not to make your life easier, but actually to make it as real as possible. Why? When you have a stack, like the memory in the computer has a stack. Okay? And do you have a limited capacity in the computer? Of course. Depending on how much memory you have, you may have 8, 4. So, but if we play with a linked list, we come with this illusion of unlimited memory, right? So if we create a stack with a linked list, we will not take care of worrying about if a stack gets full. Stacks get full, right? So we're going to use an array. And we're going to store elements in our array. Okay? And once we are going to create an array of size whatever, say size 10. And when 10 elements are there, we're going to say the stack is full. So if somebody tries to insert an element, we're going to say error, the stack is full. If somebody tries to take an element out and the stack is empty, we're going to say error. Now, with arrays, how do you get elements from an array? Well, you have to specify what position you want from the array. How do you insert elements into your array? You have to specify the element you want to insert and the position where you want to insert. Correct?
Right.
With stacks and queues, we don't care about positions. For inserting and deleting elements in an array, you need positions. But for a stack, we do not. Why? Because when you say put an element in the collection, it's understood that we have to go at the top. And when you say remove an element from the collection, it's understood that I will take the one that is on top. Got it? So, in a stack, we don't use the words insert or remove. We use the words push and pop. Push is equivalent to insert an element. And this is equivalent to remove an element. There is another one called pick. What is pick? Pick is very similar to pop, but pick just checks what's the element on top of the list. Doesn't remove any element from there. So if you do pick, the element is still there. You're just looking at what's on top. If I pick, oh, the last one to put the assignment is Shri. That's it. If I say pop, then I'll take it out. Now she's no longer part of the stack. Got it? Yes?
You return something?
Sorry?
With peek, you return something?
You just return the element that is on top. Okay? So we're gonna create a stack of positive elements, okay? Just for simplicity, I'm gonna create a stack of positive elements. And why am I saying that? Because if the element, if the stack is empty and you say pop, I will return -1 to indicate that the stack is empty. Okay? Now, if you wanna be more precise and handle a stack of positive and negative, then you have to have another way of handling empty stack, right? So let's start playing with our stack. Let's see, we have 7 more minutes. Let's see what I can do. I'll call stacks and views. Let's see if I can do both. I wonder why you're here, Christina. Okay. I'm going to call it stack. Put it like that. Okay? Now, a stack will have a capacity, right? Meaning how big the stack is, right? And I will also have another attribute called size. The first question will be, what the heck is the difference between size and capacity? Size means how many elements are inside the stack. And capacity means what's the maximum we can hold. Okay? Is that clear? So I'm going to create an array of size 10, capacity 10, and if I insert one element, the size is 1. Is that clear? So I will create my constructor. I will need to receive a capacity and nothing else, just a capacity. How big I want the stack to be. I will say stack, actually, I can do it. Capacity equal cap, right? And then stack equal meaning of capacity. Got it? And size what? 0 because I don't have any element yet. Right? Correct? Okay. Public void. You want to do push or pop first?
Push.
Okay, let's do something easier first. Boolean is empty. How do we detect if a stack is empty?
Size and
Check
zero.
size.
Return size.
We've done this last time, right? Return size equal 0, right? This is already a boolean. This can be true or false, right? Okay, let's do push. And we want to insert an element n. What do we do? The simplest idea would be to do this. The stack at position what? Well, size tells me how many have been inserted. If nothing has been inserted, size is 0. And that's the first position to insert. If 1 has been inserted, size is 1. And 1 is the second position, right? So I can always do this, right? Size equal n, right? And I could do size plus plus here, or I could do all at once. Remember I told you this?
Yeah.
Just to keep you happy today, I will do it like that. Okay? Is this good? What's one problem? Remember, I'm playing with arrays for something, right? I'm playing with arrays for something. Since I'm playing with arrays have a fixed capacity, right? So I cannot just blindly insert an element because the stack might be full. So before inserting, which is what I'm doing here, I should check if there is enough spots, right? When can I insert?
If the size doesn't
If my size is less than capacity. Less or equal? Less. Because equal, right? Exactly. Very good. Stacks are very straightforward, guys, but yet they are very powerful too. Else, you can say S out, stack is full. Sorry. Right? Now pop. I'll int because pop returns an integer. Let's do pick first. Pick is easy. Pick pretty much wants to return the element that is on top.
So you check if they're not doing it, they return -1.
Okay? Else what?
Else return.
I should return the element that was inserted last, correct? That's how stacks work, right? Which one is the element that was pushed last?
Size.
Size?
Position size.
Size minus 1. Because if size is 2, means that element 0 and 1 have been inserted. I should return stack of position size minus 1. Got it? Last element being pushed. Right? Okay. Now, the pop should be very similar, right? Again, if it's empty, return minus 1, else what? I have to return this element, right? But besides returning the element, I have to make the stack smaller, right? So let me show you this trick. Assume a stack of size 3. Very simple, okay? 0, 1, 2. Then I have two elements, size equal to, right? Element 7 and 9, for example. Which one should I return when I do pop? 9, right? And put size 2, 1. Correct? Am I really gonna erase 9? No, I will just say size 1, and with that I will understand that I only have elements at position 0. I will not do anything here. Because then if I want to push, I will override this value. So I don't need to delete this physically from there. Is that clear? Is that clear, guys? Yes?
Yeah.
Okay. I have 7 and 9. Okay? Say, how do I have 7 and 9? Okay, let's call the stack S. I do push, 7, and I do S push, and I have 9. Right? Now, somebody tells me in X equal S dot pop. Okay? Correct? Somebody wants to pop an element. So this should return what? 9, because that's the one that was just inserted, right? So how will I implement that? I should return this 9, but I should make size equal to 1 now. Got it? Correct? Do I have to do, so now size minus 1 is pointing here. Size minus 1 is always the last index, right? At the beginning, size is 2, so size minus 1 is pointing here. That's the last index, right? But if I do pop now, this is my last index, right? Am I going to physically delete 9? No, I will leave it there. Because if somebody later wants to do this, S that push 7, for example, or 17, right? I would try to insert it at size position. The size is 1, that's the position here, I will put 17. Okay, got it? The 9 doesn't count. It's there, but it doesn't count. Is that clear?
So you just change the size.
Let's change the size. And return the element.
Because it's going to get overridden. That's the
You can still retrieve the 9 if you want to go back, right?
Yeah, but how are you gonna retrieve the 9?
Can't you just make the size of 2? That 2?
Remember, the stacks has only push and pops.
Okay.
How are you gonna obtain the 9? Can you obtain it with a push? No, push inserts. Can you obtain it with a pop? No, because pop will take the one at position size minus 1, which is 7 now. Got it? So it's physically there. But the stacks only allow you to have push and pop. Can you get it with a push and pop? No. No, it's impossible. Right? Now, so here I have to return the element and make size minus minus, right?
Right.
What's the problem?
Size is 0 already.
No, what's the problem there? The problem is that you cannot return and then do size minus minus. It's going to be an unreachable statement. Right?
Right.
So here's where we get in trouble. People say, oh, professor, but if I put here size minus minus, right?
Yeah.
Then this is no longer accurate. Right?
No, you just.
Correct? Correct? Because I would like to return the element at this position first and then make the size smaller. Right?
Yeah.
So, couple of options, lame options first. Lame options are this. In original size equal size. Then size minus minus. Then original size. Got it? Got it? One lame option. I wouldn't do this. I will do this line here. I will put it here in comment. This line does everything. Okay? This little line that I just commented replaces because what it does is, you have two instructions, remember? Return and increment size. Which one should I do first? This is postfix, so I will first return at this position and then make size minus mine, which is what I want, right? So that line in gray, that's the 3 lines above. Is that clear?
So one makes it smaller and the other one too.
Which one makes sense?
Well, size minus minus makes the list smaller, and the read size minus one checks to 6 and the
Correct. Check the position, check the one on the position. It's still there. It's still there. It's still there, but it's not accessible anymore.
Another option would be that instead of creating the original size, you do size minus minus and then return stack position